Last day of complex numbers, conjugates, and solving equations. With conjugates, we have radicals or i's on the bottom again, but this time we have either a plus or a minus. Okay, so it's because of this minus sign, right, or this plus sign that makes it necessary to use conjugates rather than how we solved them yesterday. So a conjugate is basically whatever we have already, we're just going to change the sign. So instead of 7 minus radical 5, we're going to write 7 plus radical 5. Okay, and again, anything that we multiply on the bottom, we're going to multiply on the top, because the whole point is that this equals 1. Right, if we multiply by a fraction by 1, we're not really changing it. Okay, so this is what we're doing. We're multiplying by that conjugate. And the point of that is because if we multiply by a conjugate, okay, on the bottom here, we're going to have to FOIL this out. Okay, so let's see what happens. So we have first, which is 49. Now the outside and the inside. So outside 7 radical 5, inside negative 7 radical 5. These always cross each other out when we have conjugates. It's a difference of 2 squares problem. Okay, then the last one, minus radical 25, and radical 25 is always a perfect square. This just equals 5. So the whole bottom just ends up being 49 minus 5, so it switches to 44 in the denominator. The radical is gone. On the top, we're going to distribute this negative 6 into both of those, and we have negative 42 over minus 6 radical 5. Right, that's over 44. If we look at all these numbers here, we can see that they're all divisible by 2. Now, when I say they're all divisible by 2, I'm not counting this 5. Okay, I'm only looking at the coefficients. Okay, these are the numbers that can simplify. We don't need that 5 to be divisible by 2. Okay, because we only need this one outside the radical. Okay, so let's divide all those by 2 to get our answer. Negative 21 minus 3 radical 5 over 22. Number 2, we're going to do the same exact thing. So the conjugate of 4 plus 9i is 4 minus 9i, top and bottom. All right, FOIL it out. First, outside, inside, last. And when we do that, the outside and the inside are opposites. They cross each other out. First one was 16. Last one, minus 81i squared. I squared is a negative 1. So we really have 16 plus 81. Gives us 97 on the bottom. The top we distribute, and we have 8 minus 18i. Doesn't look like we can simplify this one, so that's our answer. The final thing in this section is solving equations algebraically. So we're going to do minus 11 to get this x squared by itself. Now we have x squared equals 5. And to get rid of this squared, we're going to square root both sides. Now, the thing to note is that there's really 2 answers for all of these problems. Okay, because when we square something, it doesn't matter if it's positive or negative, it's going to turn positive. So if we were to square positive radical 5 or negative radical 5, both of those would result in a 5 as the answer. Okay, so we always put this plus minus in front of our answer when we square root to get rid of a squared. All right, number 4, same idea, add 7, add 7. 3x squared equals negative 81. And all of these, our first step is to get the x squared by itself. Okay, x squared equals negative 27. So now we're square rooting. The x squared is by itself. At this point, we square root. So here you can see we have the square root of a negative. We're going to have an I here. We're going to do a factor tree. We have 9, we have 3, and we have this I. Square root of 9 equals 3. So we have 3i radical 3. And all of our answers have that plus minus in front of them. All right, number 5, minus 1. 7x squared equals negative 49. Divide x squared equals negative 7. Square root, square root. Okay, we have I radical 7 with that plus minus in front of it. I know you guys get it. There's one more problem because this combines a lot of the things that we've done in this section. So here we have this equation. First step, let's get rid of this 3, divide it to the other side. Cancels here. We have x minus 2 squared equals 40 over 3. All right, square root, because the parenthesis, which is being squared, is by itself. Square root this side. Here we have a radical around the fraction that's not going to be allowed. We're going to have to rationalize this one. Over here, these guys cancel, and we have x minus 2 left. Okay, I'm putting in this plus minus now because we've square rooted to get rid of that x squared. All right, so we have plus minus radical 40 over 3. Eventually, we're going to have to get rid of this 3 inside the radical on the bottom. But before we do that, let's get rid of this or break down this 40. Okay, we can simplify this, break down the 4 and the 10. Okay, and when we do that, we see we have a pair of 2's. These don't have partners, so they're going to combine back together into a 10. So this whole thing turns into 2 radical 10. All right, so here's our updated problem so far. All right, so now let's get rid of this 3 on the bottom. So times radical 3 times radical 3. Okay, this is going to turn into a 3. Actually, it's over here. So we have a 3 here. And this is going to turn into a radical 30. All right, so now we have x minus 2 equals plus minus 2 radical 30 over 3. Just to note, you can't divide these. One's inside a radical, one is not. Last step, move this 2 to the other side. So we're going to add 2 to both sides. X equals 2 plus or minus 2 radical 30 over 3. That's a fine answer. You're done. If this were a standardized test like the SAT, they might make it into one fraction. So they would give it a common denominator, change that 2 to 6 over 3, okay, and then make it into one big fraction, 6 plus minus 2 radical 30 over 3.